After solving an equation, we can always make sure that it fits all three levels of understanding what an equation is and what solving an equation means. Another way to mathematically check that we're correct is by checking for true or false statements. A true statement is that an equation states two values are equal. 3 equals 3, 5.8 equals 5.8, negative 12 equals negative 12. These are all true. These values equal each other. A false statement is when an equation states two values are not equal. 3 equals negative 3. That's a false statement. They are not equal. 5.8 equals 58. They are not equal. Negative 12 equals 17. They are not equal values. Our goal is to find values for our variables that can be substituted in to create true statements. If the equation starts balanced, it must end balanced. To check if your answer is a solution, plug or substitute your solutions back in. If you get a true statement, your answer is in fact a solution and you solve the equation correctly. So we start by substituting your potential solution or solutions back into the equation. We're going to check if x equals negative 5 is a solution to 3x equals negative 15. We would either be given this problem or this solution to check, or we could do this at the end of solving 3x equals negative 15. So I'm going to substitute it in 3 times x. I'm going to leave a set of parentheses so I know where to plug my value in. And I'm going to substitute negative 5 in. Next, I'm going to evaluate both sides of the equation. 3 times negative 5 equals negative 15, and the other side is already negative 15. Check if you have a true statement or a false statement. If you get a true statement, your answer is a solution. Negative 15 does equal negative 15. So that means x equals negative 5 is, in fact, a solution. I solved the equation correctly. This goes back to our level 1 understanding of what solving an equation means. We're finding a value, a solution to an equation. This value can be substituted back in to create a true statement. Let's try a couple here. So x equals negative 3. Let's check if it's a solution. I'm going to replace my variable with x equals negative 3. 3 times negative 3, so I'm going to evaluate both sides. I get negative 9 equals negative 9. That is, in fact, a true statement. X equals negative 3 is a solution. If I had just solved this equation and negative 3 was my solution, I would be correct. Is x equals 4 a solution to 8 equals x plus 12? So I have my equation, I replace my variables with parentheses. Instead of x, I'm going to put 4 because x equals 4. They're interchangeable. I can substitute it in. Evaluate both sides. 8 is still 8. 12 plus 4 gives me 16. This is not a true statement. 8 does not equal 16. So in this case, x equals 4 is not a solution. If I had solved 8 equals x plus 12 and got x equals 4 as a solution, I would have to go back to the beginning of my equation and resolve. If you find a false statement like this, double check that you checked your solution correctly. Make sure that 4 plus 12 does in fact equal 16. Make sure that you plugged 4 into the right place in the equation. If there are no errors there, that means you solved the initial equation incorrectly. On your own, try the next two. Take the solutions and check if they work. Check if they create true statements when substituted into those individual equations.